All right, so this is the last video you had to watch before class, and this is the one that you should be sending me a picture of filled out in your lecture notes. So this could be a screen cap if you're using something writing on a screen, or just take a picture on your phone and then email it to me. I'm going to regret very much asking for this, but I do want to be able to check your guys' lecture notes, and I can't do that if I'm not there. I'm not going to make poor Professor Steele do that. So tree diagrams are another set of diagrams that we can use, and they're particularly useful if we have conditional probabilities. So, give myself a little more space to write. We have a nice little exercise here about whether or not students attend a final review session. So again, we'd want to read through this, sort of figure out what our events are, and in fact, I'm just going to start us off by looking at this last sentence here. They've gone ahead and translated all the different things that we need to be looking for as we read. So we have attending a review session, not attending a review session, passing, and not passing. So we could have used the complement notation for these because this is attend and not attend, right? We could have used a complement, but they've told us to use N, which is completely fine. So these are the things we're looking out for. Passing, not passing, attending, not attending. So as you start reading, the first thing I notice is the word given, which I know is super important in terms of putting a line, right? Attend a review session. There's our A. They have a 90% chance of passing, which is our P, right? So we know A goes behind the line, pass 0.9. By the way, this tree diagram is our warm and fuzzy for exam 2. This is Andrea or Professor Steele will be going through exercise 5 with you guys at the beginning of class on Tuesday or Thursday. So I'm going to skip that exercise. I'll do exercise 6 so you guys can see another example if you really want to. If you want to make sure that you go into class and you can finish that worksheet super quick. But there's 3 of these in the notes. You'll look at all the old exams when I post up the exam 2 review folder, and you'll see that this is the first question on every exam. So this is your warm and fuzzy. We're going to practice the heck out of this so that we get all the points at the beginning of exam 2. All right, so let me just finish this translation. I got to feed my child. Next thing, again, we see and given they don't attend, which they told us to use N, the review session, they have a 15% chance of passing. So the probability of passing if they don't attend has now dropped drastically from 90% to a 15%. And we've got one more percent here. The professor estimates that 75% will attend. Nothing about passing or not. So there we are. So I will be right back. You guys will not notice this break in time to feed my child, and then I will finish this. Through the magic of the pause button, like 2 hours have passed, but you have only seen seconds. So now that we have these different probabilities, I want to show you how this tree diagram works. So the tree diagram essentially lets us see a bunch of different possible paths. I think of it as like a choose your own adventure. So what we want to start with is we're going to basically start with all students, right? So at all students, we have 100% of people. And then there's 2 paths these students can take, right? They can either attend the session, the review session, or they can not attend. And we know which way we're going to do the original split or this initial split based on whichever probability we have by itself. So in this case, we have attending. So even if these weren't filled in, we'd know what we needed to start with. So if 65% of students attend the final review session, that means 35% of students must not attend that final review session. So these are always going to be complements of one another. So I only have to give you 1, and you've got 2. Now, once that decision is made, once that piece of the adventure is chosen, there are 2 possible timelines that we can continue on, right? They could either pass the final exam, or they could not pass the final exam. And again, we know what this is. If they've already attended the final review session, there's a 90% chance they pass, which means the probability that somebody who attended the review session doesn't pass is 10%. Again, summing up to 1. We've only given you 1, but you actually got 2 of these probabilities. And then the last piece, passing for not attending. Again, we now know of all the people who didn't attend, they also have two options. They could pass or they could fail. And their pass rate is only 15%, which means 85% of them fail. So all of these pieces are basically going to be given to you, and we have a bunch of different complements being used to give us a little bit more information than we had originally. Now, if you remember, the and probabilities are all about multiplying by a conditional and then whatever we knew behind the line. If we multiply those together, we're going to get the probabilities of the ands. So that times 0.9. So if we multiply down this next branch, 65% chance they attend. And then of those who attend, 10% chance they fail. And we're just going to go ahead and find all of these different probabilities by multiplying down our branches of our tree. And what should happen at the end, we have all of our ands, which are the 4 pieces of a Venn diagram. So just like in a Venn diagram, all of this, whatever we get out, should sum to 1. And this lets us know that we haven't made any mistakes. So other things to note about this in terms of that worksheet this coming week, in terms of the warm and fuzzy question on the exam. The way this will look different on the exam is I'm going to leave all of these probability notations blank. So you need to know what goes into each of them. So we have our initial split, which is just a marginal, something that we had by itself. We then have the givens with what we knew behind the line, because we now know, okay, this has happened in terms of our timeline. And we have our ands, which is what we result in at the beginning, or at the end. So I did have a colleague at SDSU, another TA, when I was teaching there as a teaching assistant, who came up with this like little saying about in the PGA Tour, you try to avoid trees, blah, 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 avoid. And what matters here more is this idea of PGA. He meant for P for probability, G for the givens, and A for the ands. So this reminds students exactly what notation to use where. So you have that in your back pocket, or as always, since you know this is coming, you know it's warm and fuzzy, maybe some note card fodder in terms of the notation, because this is usually 2 or so points of the actual question, is having the notation correct. All right. And then once we finish this, we can answer all sorts of questions. In this case, we said what percentage of students passed the final. So only about P. And if you want to, one of the things you can do is once we have all the ands, we could actually make our little contingency table. And on the exam for the warm and fuzzy, there's going to be 2 follow-up questions, if not 3. So it's sometimes worth it to take some time to do the table. So on the table, remember, we need the ands to intersect. So we need A and P to intersect because we have that and. Next to A, that's attend, we're going to have our not attend. Next to pass, we're going to have our not pass, which is our F. And then we'll have our total sections. And I'm just going to grab each of these different pieces. A and F is 0.065, P and N 0.0525, N and F 0.2975. And I can even add up these rows, and we're going to get back out the 65 and 35 that we split up from here. And if we add these up, we're looking for this right here, this pass, and we can see that's just going to be 0.585 plus 0.0525, so 0.6375. And as for this is a percent, so I'll go ahead and rewrite this as a percentage. Now, you could have done this straight from the thing, or straight from these ands, by just grabbing the 2 things that are pass, right? If we're talking about passing the final, we don't care if they attended or didn't attend. We got to take both of those and add them back together. Last note here, you will likely not use any of these probabilities at any point after you make the tree. Once you make the tree, you're going to use the final 4 probabilities to answer all the questions that come next, most likely by making a cute little table. So this is what we're going to be doing in class. This is what the worksheet is. It has you take this, create it. The hardest part is getting these notations correct, but you know what's coming because you know we're making a tree, so you have to have 2 of these givens and a thing by itself. And highly recommend that you check with some friends before you finish up the tree, so that way you make sure your notation is correct.